Okay, so this is part 2 of 6-1, and we left off talking about the ambiguous case, again where we have a side, and then an angle. So here we have side A is 51, side B is 71, and angle A is 75 degrees. So a side, another side, and then an angle. So we know that it's possible that we could have either two triangles, no triangle, or we have a triangle, or maybe even a right triangle. Now, I'm going to go ahead and solve here. Let's set up what we already know. We know this is 75 degrees, we know this is 51, and we know this is 71. So again, we have to solve for that angle B. So sine of angle B over side B, which is 71, equals sine of angle A, which is 75, over side A, which is 51. Sine of B is going to be 71 sine 75 over 51, which gives us, when we plug in our calculator, about 1.34. Now, if you try to do inverse sine of this, inverse sine of 1.34, it's going to go to an error. And the reason why is because sine always stays between -1 and 1. This is too big. Remember, sine stays between 1 and -1. It never goes up to 1.34. So what that means is no triangle exists. Now notice for this example, I still have all my work, I'm still showing all of this, because when I started this problem, I didn't know that this would happen. So on your homework or on a test or anything like that, if you have this situation, I shouldn't just see this, I should still see some work here, okay? So let's go on to our next example. So we've seen a few different things happen. We've seen the ambiguous case where we have a triangle. We've seen the ambiguous case where there's no triangle. Let's see if we can find out what happens if we have two triangles that exist. So 40 degrees, we're just putting our information down here. And we need to set up our box. So angle A, angle B, angle C, side A, side B, side C. And let's go ahead and fill in what we know. We know that angle A is 40, side A is 54, and side B is 62. So we need to find that side B. So sine of B over 62 equals sine of 40 over 54. Sine of B equals 62 sine of 40 over 54. And angle B will be inverse sine of all of that stuff brought down in here, that decimal. Why don't we go ahead and actually just calculate that? So sine of 62 sine 40 divided by 54 is about 0.738. And then we'll do inverse sine. And we get 47.6. Let's just say 48 to make things simple. Okay? Now, we need to check and see if two triangles exist. So what we're going to do then is say, okay, well, if 48 plus 40, I'm sorry, before we do that, we need to check and see if there's another triangle that would give us the same thing. So remember, if I have 48 degrees, there's another angle over here that could give me the same 0.738 when I take the sine of it. So 180 minus 48 gives me 132. Now if 132 plus my original angle 40 is less than 180, then there exists two triangles. Okay, so let's go through those steps again. We found angle B, then we did 180 minus angle B, and if that new angle plus our other angle is less than 180, that means there are two triangles. Okay, so we need to set up a box for another triangle. So this is triangle 1 and triangle 2. So angle A, angle B, angle C, side A, side B, and side C. Okay. So for the given information, it's all going to be the same, but the rest of this will be different. So we found that for triangle 1, this is angle B, and I'll just put a 1 there. It was 48 degrees. And then we can find C and side C. And this 132 is our B2. Okay. So side C, or angle C and angle C2, we need to go ahead and find. Okay, so let's go ahead and find C1 here. So angle C1 is 180 minus 48 minus 40, which is going to be 92 degrees. And then C1 over sine of C2. And then we can use either one of these. I'm just going to go ahead and use the one I have here. So we have 54 over sine 40. So C1 is going to be about 84. Okay. Now we can do the same thing for C2. So angle C2 is 180 minus 132 minus 40, and that would be 8. And then C2 will be sine of 8 equals 54 over sine 40, and C2 will be about 12. Okay, and that's how we address the ambiguous case when we have two triangles. Now this is a really tough concept. It is something that it's hard to keep track of everything. So if you're working on the homework and you're struggling with this, make sure that you come and ask me questions. Now we only have one more example left in this section, and that's how to find the area. Now you're familiar with the area of a triangle equals 1/2 base times height. But what if we don't have a base and a height? What if we have an oblique triangle and we just know those relationships? So these are our new area formulas. Okay, so 1/2 B times C of sine A, or 1/2 if you're given that information, and then if you're given that information, that's what we have as well. These are three separate formulas. So let's go ahead and do this last example. So it says find the area of a triangle with sides of 8 and 12 and an angle, an included angle of 135. So it says an included angle of 135, and what that means is that it's between 8 and 12. Okay. So the area equals 1/2 base or B times C of sine A. So we'll label this A, this B, and this C. That would make this little b and this little c. So the area would be 1/2. Little b is 12, little c is 8. Sine of angle A, which is 135. And typing all of that in our calculator, we have 33.94 units squared. Okay, and that's the area of this triangle. So with that example, that brings us to the end of 6-1.